Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we solved question number 1 of exercise number 5.2 related with chapter number 5 integration relevant with the topic of integration of definite integral through the method of substitution. In today's video, I am also the same topic which is already learned in the previous question number 1, the indefinite integral through the method of substitution, but over here we will integrate indefinite integral just a trigonometric function. In the previous video there were also an exponential function. So let's move toward the question. Evaluate the following indefinite integral by the method of substitution. In this question there were just a trigonometric functions given, just like in the part A that tells that integral of tangent 2x secant 2x dx. Find their integral. You know that derivative of secant x was equal to the secant x and tangent x. So now replace x with 2x, it becomes secant 2x. Derivative of secant 2x will be secant 2x tangent 2x. But here we were also taking the derivative of this inner function which gives us 2. So the derivative of secant 2x were 2 secant tangent 2x. But over here in integration, we will write, let's suppose 2x is equal to u. So taking the derivative of both sides with respect to x, so it becomes du by dx will be equal to 2. Now shift 2 to this side and ds to the right hand side, so it becomes du by 2 is equal to dx. So now suppose put these two values in the given integral, it will become very easy. So integral of tangent 2x, so tangent time of 2x is u and secant time of 2x is also u. And after this dx is du by 2. So du and 1 over 2 can be written as outside of the integral. But after this 1 over 2 time up, you know that tangent 2 and secant 2 just like secant x and tangent x. So secant x and tangent x just like tangent to secant u comes from the derivative of secant x. So over here we will write secant x secant u. Because secant u derivative is tangent to secant u, these are the opposite phenomena, integration and differentiation. Now after this secant u divided by 2 plus constant of integration. Now u is not the given function. Over here the given function is 2x, so put 2x over here. So 1 over 2 time of secant time of u is 2x, so replace u with 2x, so it becomes 2x plus constant of integration. So this is the required indefinite integral for the part number A. Now move to part number B of question number 2. This is question number 2. So part number B tells that integral of 4 secant square 4x dx. Find the indefinite integral through the method of substitution. Let's suppose in this part number B, 4x is equal to u. Now differentiate both sides with respect to x, so it becomes du by dx will be equal to the 4. Now over here we have 4 dx. So it means that we will shift dx to the right hand side. So du will be equal to 4 dx. Now put these two values in the given integral. So integral of secant square 4x is actually u and 4 dx is actually du. Now you know that in the differentiation derivative of tangent x was secant square x. So here we have secant square u. So its integration will be tangent u because these are opposite phenomena. So tangent u plus constant of integration. Now replace u with the given 4x. So it becomes tangent time of 4x and plus constant of integration. This is the required integration, because if we differentiate tangent 4x, so tangent x derivative is secant square 4x and derivative of 4x is 4, so it will give us again 4 secant square 4 dx. Now move to part number C, integral of tangent x secant square x dx. Find the indefinite integral. Let's suppose in this part number C, tangent x is equal to u. Let's suppose u is equal to tangent x. Now taking the derivative of both sides, so du by dx will be derivative of tangent x is secant square x. Now over here we have secant square dx, so dx will shift to the right hand side, so du will be equal to secant square x and dx. So let's suppose put these two values in the given integral. So the given integral will become tangent x is u, secant square dx is du. Now over here we will use the generalized power rule of integration, which tells that x power n dx will be equal to the x power n plus 1 divided by n plus 1 plus constant of integration. We will just put 1 in the power and in the numerator with the given power of this variable. So it becomes u power, this is, let's suppose n, so add 1 with it in the power. and apply the same logic in the denominator and plus constant of integration. So it becomes u power 2 divided by 2 plus constant of integration. U is not the original and specific variable. Our original function is tangent x, so put tangent x over here, so it becomes tangent x whole square divided by 2 plus constant of integration. This is the required indefinite integral. Now move to part number B. It tells that integral of tangent 3x plus secant 3x multiplied dx. And now move towards solution. We will take the integration on tangent 3x and secant 3x dx separately. So it becomes integral of tangent 3x is multiplied with dx. So tangent 3x dx plus integral of secant 3x multiplied dx. So secant 3x multiply dx. Now after this we can write tangent 3x just like sine 3x dx divided by cos of 3x, because sine 3x by cos 3x again gives us tangent 3x plus integral of secant 3x and dx. Now after this, let's suppose if we put cos of 3x is equal to u. Here I multiply and multiply minus, because minus multiply minus gives us again plus. So let's suppose cos of 3x is equal to t, taking the derivative with respect to x on the both sides. So dt by dx will be derivative of cos x was sin x. So here is cos 3x, so it becomes negative sin 3x. Negative sin 3x. Also take the derivative of the inner function 3x. Its derivative is 3. So minus 3 sin 3x. So our dt will be minus 3 sin 3x and dx. But over here we have negative sin 3x dx. Negative sin 3x dx. So it becomes dt divided by 3 minus sin 3x and dx. Now after this put these value in the given integral. So it becomes minus time of integral of minus sin 3x dx, which is dt by 3. So 1 over 3 will out of the integral and dt. And over here we have 1 over cos 3x. So 1 over cos of 3x was supposed to be taken t. So 1 over t minus sin 3x dx is dt by 3. And we have another minus sign outside of the integral and plus of. You know that the integral of secant x is ln of secant x plus tangent x. Ln of secant x plus tangent x. But here it is 3x. So it becomes secant 3x plus tangent 3x. You also know that in the integration we also take the derivative of this inner function in the denominator. So the derivative of 3x is 3, so we will take in the denominator. So it becomes 1 over 3. After this it becomes minus 1 over 3. Remember, the integral of 1 over t is ln of t, because if we differentiate ln of t, it gives us 1 over t. So it becomes ln of t. After this plus 1 over 3 ln of secant 3x and plus tangent 3x. Now after this replace t with the given cos of 3x. So it becomes first we are going to take out 1 over 3 common. So inside we are left with ln of secant 3x plus tangent 3x. And here if we supposed to be taken 1 over 3 common, we are left with minus time of ln of t is cos of 3x. So cos of 3x. Now we have logarithmic formula ln of a minus ln of n, which is equal to the ln of a secant 3x plus tangent 3x divided by cos of 3x. So this is the required indefinite integral. Now move to part number E. Integral of cos square x divided by cosecant x dx, find the indefinite integral. So we can simplify this integral just like you know that here we can write it 1 over cosecant x multiply cos square x and dx. You know that 1 over cosecant x is actually equal to sin x, because these are the reciprocal of each other. Sin x is 1 over cosecant x. So put sin x over here. So it becomes integral of sin x cos square x dx. Now over here I multiply minus and minus. It cannot affect the given integral. It again gives us plus. Now over here I suppose to take an cos x. Let's suppose this is t. T is equal to cos of x. So now differentiate both sides with respect to x. So dt by dx will be cos derivative of x is negative sin x. Over here we have negative sin x dx. So dx will shift to the right hand side. It becomes dt is equal to negative sin time of x and dx. Now put these two values in the given integral. So minus time of integral of minus sin x dx is dt and cos square x. So cos x is t, so it becomes t square. T square minus sin x dx is dt and minus dt t square. Now using the generalized power rule of integration, x power n dx will be equal to the x power n plus 1 over n plus 1. Just add 1 with the power, so it becomes minus time of t power. Here it is 2, so 2 plus 1, and also apply the same logic in the denominator, 2 plus 1 plus constant of integration. So it becomes minus t power 3 divided by 3 plus constant of integration. Now replace the t with the given cos of x, so it will be required result of. So minus time of cos of x whole raised to power 3 divided by 3 plus constant of integration. This is the required indefinite integral. Now move to part number F, integral of cotangent root x dx by root x. Over here we are supposed to be taken u is equal to root x. Now differentiate both sides with respect to x, so it becomes du by dx is equal to, you know that x root can be written as x power 1 over 2. And if we differentiate x power 1 over 2, so it will give us du by dx will be equal to 1 over 2 will come to the front and subtract 1 in the power. So it becomes x power negative 1 over 2. So it becomes du is equal to dx will come to the right hand side and it can be written as 1 over 2. Here the x power is 1 over 2. So if it comes to the denominator, so the power will become x power 1 over 2, which can be written as just root x. Now over here we have dx by root x. So it means 2 will come to the left hand side. So it becomes 2 du is equal to dx divided by root x. So this value and this value will be used in the given integral. So integral of cotangent root x is u, and dx by root x is just 2 du, so it becomes 2 times of du. Now after this we can write it just like to integral of cotangent u can be written as cos of u divided by sin of u du. Now let's suppose here we take on sin u is equal to t. Sin u is equal to t. Now differentiate both sides with respect to u, so it becomes dt by du is equal to sin u derivative is just cos of u. Over here we have cos u du, so du will shift to right hand side, it becomes dt is equal to cos of u and du. Now put these two values in the given integral, so it becomes 2 times of integral of cos du. Cos u du is dt and divided by sin u is t. Now you know that 1 over t integral is just ln of t, so it becomes 2 times of ln of t plus constant of integration. So the value of t was sin u, so it becomes 2 times of ln of sin u plus constant of integration, and also replace this u with root x, so it becomes 2 times of ln of sin time of u was root x, so 2 ln sin root x plus constant of integration. So this is the required indefinite integral. If we differentiate this term, it will give us cotangent root x by root x dx. So this is the required indefinite integral. Now move to part number G, integral of sin x minus cos x dx divided by sin x plus cos x. So let's suppose over here we are supposed to be taken sin x plus cos of x. Let's suppose this is equal to the variable w. Now differentiate both sides with respect to x, so it becomes dw by dx will be equal to the derivative of sin x is cos x, and the derivative of cos x is negative sin x. Now after this it becomes dw will be equal to the, now after this over here we are supposed to be taken negative common, so inside we are left with sin x, and here it becomes negative cos of x, and here it becomes dx. Now shift this minus to the this side, so it becomes minus w. So integral of sin x minus cos x multiply sin x minus cos x multiply dx, this is equal to the negative dw. So negative will come out of the integral, and w divided by sin x plus cos x was supposed to be w. Now you know that integral of 1 over w is ln of w, so it becomes minus time of ln of w plus constant of integration. So it becomes minus time of ln of w is sin x plus cos x and dx. So sin x plus cos of x and plus constant of integration. Now over here we can also write it just like this. We can also take ln of 1 minus ln of sin x plus cos of x and plus constant of integration, because ln of 1 gives us a value 0 which doesn't affect this minus ln of sin x plus cos x. So now use the formula which is ln of a minus ln of n, so it becomes ln of 1 over sin x and plus cos of x plus constant of integration. This is also the required result, and this is also the required result too. Now move to the last part of today's lecture, question number 2. It is that integral of sin x dx divided by 3 plus 2 cos x. So let's suppose over here I supposed to be taken, let's suppose z is equal to 3 plus 2 cos of x. Now differentiate both sides with respect to x. So dz by dx will be equal to derivative of a constant 3 is 0. And here 2 times of derivative of cos x is negative sin x. Derivative of cos x is negative sin x. Over here we have sin x dx. So let's suppose I multiply and also multiply minus and minus because it gives us plus of. So it becomes minus sin x dx. So dx will come to this side and d2 will come to this side. So it becomes dz by 2 will be equal to minus sin x and dx. So put this value and this value in the given integral. So it becomes minus time of integral of minus sin x dx is dz by 2. So 1 over 2 and dz. And here we have 1 over 3 plus 2 cos x is z. So it becomes minus 1 over 2, 1 over z integration is ln of z and plus constant of integration. Now replace z with the given 3 plus 2 cos x. So minus 1 over 2 ln of 3 plus 2 cos x plus constant of integration. This is the required indefinite integral. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics. Thank you.